Right, 8. Let's hope this one's a bit nicer. A bag contains only red and blue. Someone's picking out a bead at random, notes its colour, puts it back. Faria does this 10 times and gets a red bead 7 times. Faria says there are more reds than blues in the bag. Comment on her statement. So what is she saying? She's saying she thinks basically because there's loads of reds compared with everything else when she pulled them out, she thinks there must be more reds. Well, in probability, that's likely to be the case, but not guaranteed to be the case. And she's only done it 10 times. Could have been a fluke. So I've basically got to say all that jibbly-jibbly I just said there. I just got to say that in a neat sentence. Something along the lines of, it's likely that there are more reds, as 7 out of 10 is over a half. That's what I'm thinking. But it's not guaranteed because it could have been luck with only 10 trials. You know, if you spin a coin like 3 times, you could get 3 heads in a row. Doesn't mean that the coin's dodgy. Yeah, with only 3 goes, you can get that luck. But if you spin a coin like 1,000 times, you're not going to get 1,000 heads. You see, you need more trials to get better results. So the more trials, the better is what this question's about. So bearing that in mind, it's putting that seed in your head. The more trials, the better, right? So then you read the rest of the question. They are all doing the same thing. These guys, you know, they love it. They love spinning coins and picking things out of hats and all sorts. That's their thing, right? So they're all doing 10 goes each. Faria gets 7 reds, and Rosa gets 6, and Shamila gets 8, and Tess gets 6. They all had 10 goes each, and they've all got slightly different results because they ain't done it enough times. But what you can do is you can combine their results together and get more reliable results. So you could say, all together, what's happened? All together. Because it says, use these results, work out the best estimate of probability. So you could say, well, Faria's estimate was 7 out of 10, and that one was 6 out of 10, and that was 8 out of 10, but that's no good. Put it all together, and you got it out of 40. And when you get it out of 40, you got better results. So I want to do it out of 40, right? I want to put all their scores together and see how many reds out of 40. So you just got to add this up. 7, 13, 21, plus 6, 27. I'm seeing 27 out of 40 there. I don't want to go on about that too much, but it's the more times you do something, the better your results will be. Right. Hey, oh, hello, we've got more. In another bag containing beads, 60% of the beads are green. Faria's going to pick out two beads at random from the bag. She says, probability of both beads being green is a third as you work out 6/10 times 5/9. In another bag containing beads, 60% of the beads are green. 60% of the beads are green. Faria's got, now this is weird because it's not telling us whether she's putting it back, is it? In another bag containing beads, 60% of the beads are green. Faria is going to pick out 2 beads at random from the bag. She says probability of both being green is a third as you do 6/10 times 5/9. Now the issue here is, it sounds like she's not putting the first bead back by the way that's written. And if it was out of 10, this sum would be right because, you know, like you take the first one, 6 out of 10 chance, and then it drops down to 5 out of 9. But the thing is, it doesn't tell you that it's 10 beads. It just says it's another bag containing beads, and it's 60%. So it could have been out of 100. So it could have been like 60 out of 100 times 59 out of 99, and that's a completely different sum to that. So I think the point of this question is for you to say, not necessarily, because it depends how many beads you started with. right? And it does, because 60 over 100 times 59 out of 99 is not the same as 6 out of 10 times 5 out of 9. You've got to have, you need a fraction that represents the amount of beads there are to start with. You just don't know. So that's what that question's about, getting you to think a bit. Number 9, classic algebra. This has changed the subject, so this won't take too long. We've basically got to do a bit of balancing and make Q the subject. Right? Now, really, the way you should have been taught this is to do balancing. That's certainly the way I would have taught it. I'd have said add 7 to both sides, P plus 7 equals 4Q. And then I would have said divide by 4 both sides, P plus 7 over 4 equals Q. Job done. Hopefully one of them is the answer. Oh, look, there it is. All right? So trust your algebra. They're always the easiest questions if you train yourself with algebra. Right, what are we on? 10. How are we doing? 10:45. All right. 3 maths teachers. 12 homeworks in an hour, 30 homeworks in 2 hours, 1 homework in 6 minutes. Show that Kira is the quickest of the 3. Right, so basically you've got to just make them all the same amount of time. So let's make them all an hour. So Jeremy equals 12 per hour. Kira equals, well, if that's 2 hours, that's like 15 per hour. And Liz, well, 6 minutes, 60 minutes is an hour. So she's doing like 10 per hour. So Kira is doing more per hour. It's easy, that, isn't it? Question 10. One night, Jeremy and Kira work together to mark 36 homeworks. They both start at 4:30 and work until all the homeworks are marked. What time do they finish? Ugh, what a pain. Right, anyway, we've got some pain marking homework, I'll tell you that. But anyway. So we've got to do 36 homeworks, and they're doing like 12 per hour, 50. Let's go back to the original numbers, because it might work better with them. Because Jeremy is doing 12 an hour, and 12 fits into 36, doesn't he? So Jeremy, because he does 12 per hour, you just got to do like 3 of them, 3 hours. 3 times 12 is 36, so that's easy. Then we've got to compare that with Kira. Kira's doing 30 homeworks in 2 hours. She's trying to get to 36. So you've got to somehow get 30 to become 36, haven't you? Well, all right. Let's do it. You can do it in fractions. You can do it in ratio. I'd probably be looking at changing it to minutes temporarily, because that might be it. So if I do a little bit of ratio, just to make a change, yeah, do a bit of ratio. If it's 30 homeworks in 120 minutes, right? And we've got to try and make that to be 36 homeworks. So I know that the link there is between those two numbers is like probably the number 6. So I'd consider going divide it by 5, right? So that's like 6 as we want, and divide that by 5, and that'll be 24. So I know that we can do 6 homeworks in 24 minutes, and now I'm going to times by 6, and that'll make it magically be 36. So I'm going to do 24 times 6 times 6. 24 sixes, so 4 6s are 24, 2 6 are 12, 13, 14, 144 minutes. All right, but we want to work in like hours really, so that's 2 hours and 24 minutes. All right? There's 2 6s, 120. There's 24 minutes left. So now we've got to work out the time. Well, if you started at 4:30, Jeremy is simply going to be 3 hours later, so that's 7:30 p.m. Whereas Kira is going to take 2 hours 24 minutes, so that's going to be 6:54 p.m. All right, now that was a lot of faff, wasn't it? For how many marks was that? 3. It's not. That's a lot of faff for 3 marks. Notice, by the way, that I resorted to ratio because I could just tell the numbers were a bit awkward. And I think when they're awkward, you can go back to ratio and it's a bit easier. All right, there may be other ways of doing it, but I went back to ratio. What, we all right? Someone putting faces? Or stuck? Not happy? Oh, work together? I thought they were doing it separately. Oh, nightmare. So that's a nightmare, that, isn't it? Let's have a look here then. So work together. Work together to mark 36 homeworks. I thought they were having a race. Right, work together. Oh, I get you. Work together. Yeah, you see, I can see you pulling a face there. I was thinking, what's up with her? Right, so they're working together. All right, so they both start at 4:30 and work until all the homeworks are marked. 36 homeworks. Well, all right, let's try see how long it will take them to do 36 homeworks. Well, they could do, Kira could do, say, 30 homeworks in 2 hours, and then Jeremy could do 6 homeworks in half an hour, and so there's all sorts of combinations you can do here, isn't there? Are they just working flat out? Are they just doing a bit each? I don't know really. I think. So if they went down the route of they're just working at a standard rate, then 15 per hour and 12 per hour. Like if this person worked for say 2 hours, they'd do their 30. And this person worked for half an hour, they would do their 6 for half an hour. So they could do it like that. They could just go like, it could all be done in 2 hours easily. You know, there's a few ways to look at this, isn't there? I'm not quite sure where they wanted us to go with that. Do they want us to be like flat out working until it stopped, or they wanted to like share the workload in equally? It's not really clear, is it? Work together to mark 36 homeworks. So this is a scenario where I'd be wanting to revisit this. I'm not happy with what they're wanting us to do. All right. Do they want us to just work flat out and see what happens until the final book's marked, or do they want them to just break this down into like nice combinations that make 36? There's a few ways of going about it, isn't there? Whoever the slowest person is going to be the limiting factor.
I would combine them, said like together, we can make 27 pages in an hour.
Yeah, but you still got to get to 36, ain't you?
Yeah,
in a neat way.
Ratio again to get down to 9
Yeah.
36.
What do you get when you do that?
36 to 80 minutes. And under 80 minutes on.
80 minutes. So you're assuming they're going together,
Yep.
working flat out until they get to the 36.
Yep.
That's cool. That's fine. I like to say this is a scenario where you have got to have a good think about it. I mean, I don't know, 3 marks. Does that take you 3 minutes to do that? About a minute. Is that because you're a genius? Yeah. All right. Well, that's fine. I mean, I'm open to debate on that one. I'm open to debate. Yeah, I'm open to debate. But that's what you got to do. You're going to get in these situations in a test where you doubt yourself. All right. And I'm still wondering whether that's fully what they want. I'm still wondering. So I would come back to that and have a good think about it later on.